compounds means we are going to fix elements into the different element to occupy the open spaces in the metals. Non-stoichiometric means they are not going to have an order in the metals. Then we come to the F block elements, the fourth block in which the last electron enters into the F orbital is called F block element. Now, in this we have only 2 rows starting from the atomic number 58 after lanthanum to the atomic number 71 and then from 90 to 103. Now, the journal electronic configuration of this block is going to be n minus 2 F 0 to 14, n minus 1 D 0 to 1, N S 2. So, in this the F block will have the energy level 2 less than the main energy level. So, if the main energy level is 7, then the energy level in which the F orbital will be filled will be 7 minus 2, that is 5. If the energy level is 6, then the energy level in which the F orbital will be filled will be 6 minus 2, that is 4. So, the elements will have the configuration say 4F 0 to 14, 5D 0 to 1 and 4S 2. Now, this block constitutes 2 series of 14 elements each, known as lanthanides and actinides. Now, first series is called lanthanides because their filling starts after the lanthanum, and the second series is called actinides because their filling starts after the actinium. Now, these F block elements are also called inner transition elements or rare earth elements. Let us see these lanthanides and actinides in the D block. See, here it is. This is lanthanum and we are going to have hafnium at 72. Now, between this lanthanum and hafnium lies the F block, and in the same way this is actinium and this is Rutherfordium. Now, after the actinium the 14 elements of F block will lie. That is why the first series is called lanthanides because they start after the lanthanum, and the second series is called actinides because they start after the actinium. Now, these D block elements are called as transition elements, and the F block elements as they lie within the transition elements, that is why they are called the inner transition elements. So, D block are transition elements, whereas F block are inner transition elements or rare earth elements. It means rare earth means that their percentage in the earth is very less, and these are radioactive in nature. Now, the lanthanides start from cerium with the atomic number 58 and the actinides start from the thorium with the atomic number 90. Now, the journal characteristics of the F block elements. Number 1, they are heavy metals. Number 2, they show variable oxidation states. As we have seen in the D block that the elements can lose electrons more than one at a time, as we had given the example of iron with the oxidation state +2 and +3. In the same way, F block elements also lose electrons more than once. So, next is they form the complexes, means their compounds are known as complexes. They have high densities, that is mass to volume ratio is high. They form colored ions. The ions formed by the metals of the F block are colored. So, we can recognize the metal from the color when actinides are radioactive in nature. That is, actinides keep on decomposing by themselves, and these radioactive materials are actually used for various activities which are good for humans, such as we have nuclear power plants based on thorium. Then that is now we see that the periodic table is divided into 4 types of elements. First are the representative elements, which consist of S and P block, that is they have the group 1 and 2 and then from 13 to 18. Then we have transition elements, which is D block elements with the group from 3 to 12, and then we have inner transition elements which are F block elements and are also called rare earth elements. In addition to these elements can be classified into metals, non-metals and metalloids. The extreme left hand side constitute the 75% of the known elements and are called metals, and the non-metals are present on the extreme right hand side of the periodic table, that is the P block, and the metalloids which show the properties of both metals as well as non-metals, that is their physical and chemical properties are actually the combination of metals and non-metals. For example, mercury. Then the advantages of the long form of the periodic table, means why do we have this long form of periodic table, what is the advantages? The first is it is based upon the atomic number, which is the most fundamental property of the element. That is, now the atomic number is considered the fundamental property, because in the chemical reactions the electrons take part, and the valence at that only the valence electrons, and the atomic number is dependent upon the number of electrons. That is why we have taken the atomic number as the most fundamental property. Then is the position of an element is related to the electronic configuration of the element. Now, in the electronic configuration we write, we provide the position to the electrons within the atom, and the last valence shell decides the position of the element in the periodic table. Then it is easy to remember and reproduce, means I can write the periodic table by myself depending upon the electronic configuration of the element. Then elements are classified into normal elements, transition elements and inner transition elements on the basis of their outer electronic configuration. Then the problem of placing the isotopes. Now, isotopes are those elements which have same atomic number at one place for each element has been solved. So, actually this point arises from the Mendeleev's periodic table, where he could not place the isotopes in the same group, because that was dependent upon the atomic weight. Now, since the isotopes have different atomic weight, so they were given the different places in the Mendeleev's periodic table. But in this case, we are saying that atomic number is the most fundamental property. That is why the elements are going to have their places depending upon their atomic numbers. Now, since isotopes have the same atomic number, that is why they are going to occupy the same period and same group. So, their position is fixed. Then the position of the anomalous pair of the elements such as cobalt and nickel has been satisfactorily explained. Now, in Mendeleev's periodic table, he could not decide which element to place first, cobalt or nickel. But in this case, depending upon the atomic number, the place of cobalt and nickel has also been decided. Then the properties of the elements can be predicted even before their discoveries. Means that there were few places which were empty, and we could explain the properties of those elements. Then the elements belonging to a particular group have similar properties. Means the elements of the S block are going to have the similar properties, of P block are going to have similar properties. In the similar way, D and F are going to have the similar properties. Now, the transition elements of 4th, 5th, 6th and 7th periods are assigned proper positions in the periodic table. Now, in Mendeleev's periodic table, we were not able to give the proper positions. We were having the last group, the 8th group, and in that we were having 3 subgroups, and we could not give the proper positions to those elements. But in this case, all those elements have been given the proper positions. Now, the defects of the long form of periodic table. Now, although the long form of periodic table has removed most of the defects of Mendeleev's periodic table, but still it has few defects, and the main defects are: the position of hydrogen is uncertain as it resembles alkali metals as well as halogens. Means hydrogen has the atomic number 1, which it can lose just like alkali metals to form the cations, and it can gain 1 electron just like halogens to form the anion. Therefore, the position of hydrogen could not be given properly, but since it has only 1 electron in the s orbital, that is why it has been grouped with the alkali metals according to their electronic configuration. In the same way, helium. Now, helium actually belongs to s block elements, but since its electronic configuration is complete in itself, that is why it has been placed with the noble metals, because s orbital can have at the most 2 electrons. Then are lanthanides and actinides. Now, these are not placed in the main body of the periodic table, but they lie as 2 different rows below the main body of the periodic table. Because if we try to give the place to the lanthanides and actinides within the main body, then the periodic table would have shifted more to the left. Only to avoid it, we have placed the lanthanides and actinides at the bottom of the main body of the periodic table. Now, let us see once again the main periodic table, in which we can see the 4 groups, 4 blocks. See, here it is. Here it is. So, these are the 2, this is the place of hydrogen, which is with the alkali metals, because hydrogen has the configuration 1s1. but it has been placed according to its electronic configuration with the alkali metals, and helium which has electronic configuration 1s2. So, it has been placed with the noble gases because its electronic configuration is complete within itself. So, these are the p block elements, these are the d block elements, and at the bottom we have these as f block elements. Thank you.